Okay, beta, again, look into this. This is again a true, false, uncertain statement. It says the conditional and unconditional mean of random variable are the same thing. Absolutely incorrect. Let me give you an example first. So for example, let's say x, when x is 10, y is 20 and 30. When x is 20, y is 30, 40, 50. Itna hi lete hain. Bas, I don't want to create a very large data set to prove the point. But a conditional mean is E of y given xi. So if I were to find out the conditional mean now, I would have done E of y given x. Here it would have mean E of y given x is 10. And here it would have meant E of y given x is 20. Now the question is, what is the expected value of y given x is 10? What will be the expected value of y, beta? So given x is 10, which means I'm only looking into these two y's. I'm only looking into these two y's. So for these two y's, I will have 20 plus 30 by 2. That means it will be 50 by 2. That means it will be 25. So the expected value of y will be 25 given x is 10. What will be E of y given x is 20? So I will hold x at 20 and I will find the mean as 30 plus 40 plus 50 by 3. And this is going to give me the answer as 80 plus 40 by 3, 120 by 3, that means 40. So the expected value of y in this case will be 40. These are the conditional means. The conditional means are the means which go ahead and put x at constant, some fix x at some value, and then find the mean of y, find the average value of y. Now the question that next arises is what is going to happen to the unconditional value of y? So if I were to go ahead and find the unconditional mean of y, I would have gone ahead and simply done this. I would have done 20 plus 30 plus 30 plus 40 plus 50. There are 5 observations divided by 5. So 50 plus 50, 100 plus 40, 140 plus 30, 170 divided by 5. And this is going to give me 34. So you see that the unconditional value of y is 34, whereas the conditional mean values of y will be 25 and 40. And we can clearly go ahead and see that E of y given xi is not equal to just E of y. It is not equal to E of y. So we can go ahead and therefore say that the two things don't mean the same thing. Only there is a special case that you need to remember. And that special case is when x and y are independent of each other. So when x and y are independent of each other, beta, then this is the case where E of xy can be written as E of x into E of y. This is when x and y are called independent of each other, when the intersection is equal to the product. E of xy is equal to E of x into E of y. Now, if this is the case, only in that case, you will notice that E of y and E of y given x will be equal to each other. Because y is not dependent on the value of x. Y ko x se farak hi nahi pada. So given that x has happened, the expected value of y will simply be equal to the expected value of y. Am I clear with that? Right? So this is a special case. So if someone asks you, okay, under which scenario will the conditional and unconditional mean be the equal things? So they will be equal only when y is independent of x and E of y will then be equal to E of y given x, right? Okay, beta.